Viewers, welcome to Interactive Medicine. In this section, we are going to discuss about the ABO blood group system. This is a brief introduction of blood group system. In this case, we are studying the antigens and its phenotype, its genotype, and blood group A has A antigen, right? If a person who known as who is coming with you and he is group A, and which means that uh, his RBC have it's not it's a blood vessel. It's not RBC. It's blood vessel, and in blood vessel we can see the RBC, and in the RBC we have the A antigen, and for blood group B has the B antigen. In the RBC you can see the B antigen. So the persons are differed based on their blood group is based on the antigen present on the RBC, not in the blood lumen. Antigens are present in the RBC surface. Blood group AB has both A and B antigen on RBC. Blood group O has not A and B antigen on RBC. Okay, I'm drawing a blood lumen and the RBC. Okay, you can see both A and B antigen on the RBCs. So the differentiating between the antigen and antibody, antigen present on the surface of the RBC and the antibody seen in the blood serum. Okay, that is the first concept. And blood group O means it does not mean that they don't have any antigens. They have antigen, the antigen known as H antigen, but they don't have A and B antigen. So I'm drawing an RBC. So they have an antigen known as H substance or H antigen. Mature RBC not have a nucleus, right? They are enucleated, but precursor of the RBC have nucleus. Even though RBC have not nucleus, how the antigens are produced? That is the question. That's why I already said that the immature RBC have nucleus. So antigens produced in the surface of the RBC from the precursor of RBCs. That is why I wrote here, because the antigens are produced from the precursor cells of nucleus. Precursor of RBC have nucleus. That is the point. Okay, for example, erythroblast. I am drawing an erythroblast. The formation of RBC is known as erythropoiesis, right? Okay, and hematopoiesis occur in the bone marrow, and from the RBC formation it is known as erythropoiesis. Okay, in the precursor RBC we have a oligosaccharide, which means that a simple chain of monosaccharides. Its own locates on the surface of the RBC, and it oligosaccharide means 2 to 10 chains of monosaccharides, 2 to 10, and you can see in RBC 2 million oligosaccharides in a precursor of RBCs. 2 million. That is the point. Okay. In the nucleus, I already said in RBC we have nucleus. In the nucleus from the chromosome 19, they produce some specific enzyme known as fucose transferase. They transfer the fucose, which is a simple sugar, transferred to the oligosaccharide. Okay, understand? in the oligosaccharide, fucose transferase transfer the fucose to the oligosaccharide. This is known as H substance. The fucose plus oligosaccharide is known as H substance. You can see in O type blood group the H substance. What is the function of fucose transferase? Transfer the fucose to the oligosaccharides. That is the point. Okay. Blood group A along with fucose transferase, they have another enzyme known as N-acetyl galactosamine transferase or transferase A. So I am drawing a precursor of RBC here and the nucleus. Here is the chromosome 19. From chromosome 19, the fucose transferase is going to be produced. You have the oligosaccharide and the fucose bind known as the H antigen, and in chromosome 9, one pair is come from male and another pair is come from female, right? So the enzyme from a gene, the enzyme known as N-acetyl galactosamine transferase. Okay, what they do? They make a cap to the H antigen, which means that they help in the transfer of N-acetyl galactosamine to the H antigen. So they transfer a substance N-acetyl galactosamine to the H antigen. So A antigen is composed of what? H antigen plus NAGA, okay, or NAGA. Oligosaccharides plus fucose plus NAGA is known as A antigen. I think this concept is clear for you, right? So this enzyme also known as transferase A. And we can discuss about the blood group B. I am drawing the precursor and the nucleus and the chromosome 19. From the chromosome 19, this we know the fucose transferase and the chromosome 9. In chromosome, what is the difference between the enzyme for group A and B? Which means that there is a small variation of this enzyme. In group A, we have N-acetyl galactosamine, but in group B, we have only galactose. So the enzyme, maybe it's known as galactose transferase, or we can commonly call it as transferase B. Okay. In surface of the RBC, we have the H antigen. Just remember, H antigen means oligosaccharide plus fucose, and along with this H antigen, we have the galactose. So the galactase transferase or transferase B or the this transferase B helps in the transfer of the galactose to the H antigen. So the enzyme here is galactose transferase or transferase B. Okay. Okay, B antigen composed of H substance and the galactose. Now you understand concept, right? So we can just make a table, the blood group A and the blood group B. In blood group A, we have the A antigen, and the blood group B, we have the B antigen, which means that antigens are located on the surface of the RBCs. Okay, it consists of A antigen consists of H and NAGA, and B consists of H and galactose. The enzyme involved in A antigen, NAGA transferase, B galactose transferase or transferase B. In A antigen, the enzyme also known as transferase A, and both have the they are produced from the chromosome number 9. We know from the gene the enzymes are going to be produced. Okay. Phenotype. Phenotype, which means the physical character, that is blood group A and blood group B. Okay. And the genotype for A have capital A, that is homozygous. Capital A and O, it is heterozygous. Genotype for B is capital B, is homozygous, and capital B and O, it is heterozygous. Okay, I am drawing a chromosome of chromosome number 9. The genotype of blood group A and B. Okay, which means that if the both alleles are expressed, which means that both alleles can be expressed. Okay, that is capital A. But in chromosome 9, if only one allele expressed and another is not expressed, it is capital A 0 or O. So we can write the homozygous and heterozygous here. Okay, and for chromosome number 9 for blood group B, both alleles for transferase B are expressed, that is capital B and homozygous. And if only one allele expressed for transferase B, that is capital B 0, that is heterozygous. Okay, that is the concept. Okay, blood group AB. I am drawing the precursor of RBCs and the nucleus. In nucleus we have the chromosome 9. One pair is from father, one pair is from mother. Any of the sex, one allele contain transferase A and another allele contain transferase B. So both are expressed at the same time. Okay, I am drawing the H antigen in the RBC surface, and one H substance and the top connected with the NAGA and another oligosaccharide, the H substance connected with the galactose. So genotype and phenotype in this category have only one, that is capital A, capital B. That is the important, right? They have only one genotype and only one phenotype. And blood group O. In one thing I need to additionally add, that the AB blood group acts codominantly expressed. Okay, and the blood group O, we have the chromosome 19 normally function, and they produce fucose transferase, and these fucose attached with the oligosaccharides. This is known as the H substance. But in chromosome 9, it becomes mutated. It contains the mutated genes. So there is no expression of transferase A and transferase B occur. That is why we have no antigens on the surface of the RBCs, right? Which means that no A and B antigens. That is the specific type, right? We have the antigen, that is H antigen, but we don't have A and B antigens on the RBC surface. That is why we can give or donate the blood to anyone, no matter. Antigens, the genotypes. Blood group A have IA or IA, I0 or IO. B have IB, IBIO. Okay, dominant A express in case of blood group A and dominant B express in case of blood group B, and AB, IA, IB, which acts both are expressed at the same time, which is that codominance, also mean codominance, and O antigen, IO, and no antigen and antibody present on the its expression. No antigen and no A and B antigen expression. For O, there is no expression of A and B antigen expression. Okay.